presentation, we are going to discuss about what is a microprocessor and what is a microcontroller. In my previous lecture, I have discussed about what is a microelectronic circuit. Why we discuss about microelectronic circuit is that because this microprocessor and microcontrollers are a microelectronic circuit. We all know that microelectronic circuit is otherwise known as a integrated circuits. These integrated circuits are of two types, namely analog ICs and digital ICs and hybrid IC. What is this analog IC is that it is a continuous signals, okay, sine wave. What is this digital IC? Digital IC takes only discrete signals which is of only binary values, zeros and ones, okay. What is this hybrid IC? Hybrid IC is the combination of both analog and digital. Okay, this is a continuous signal and it is a combination of both analog and digital signals. Okay, so in this microprocessor and microcontroller, we are using an IC as a digital IC. So digital IC means it will take values of only zeros and ones. Okay, this microprocessor and microcontroller is nothing but a single IC. Okay, here we can use, if we am using a microprocessor, this is a IC number. If I am using a microcontroller, I can use, there are many types of ICs in microprocessor and microcontroller, but very often we are using this 8085 and 8051. To know about this integrated circuit only, I have explained in my previous video what is a microelectronic circuits. Okay, this session will discuss about what is microprocessor and what is microcontroller, what is the differences between a microprocessor and microcontroller, why we are using microcontroller in a day-to-day life applications. See, what is a microprocessor? Microprocessor is mainly used in a computer system. Okay, computer system means we all should know about what is a computer system. Computer system is consisting of a hardware, okay, software and an operating system. Okay, so this microprocessors are often used in a computer system. So in a computer system, this all should be gathered together. Without a OS, computer system will not run, and the computer system will perform multiple tasks. So that microprocessor will perform multiple tasks. Okay, so what is a microprocessor? It is nothing but one IC, okay, which it performs all the functions of a CPU. Okay, this is a IC. Okay, in this IC, we are going to implement what are the functions that CPU will perform in a computer. The single IC will perform all those functions. So what are the functions that CPU will perform? CPU will mainly perform an mathematical operations, that is ALU function, and it controls the signals, okay, and it stores all those in a registers. Okay, these are the basic functions of a CPU. Okay, so in a computer system, where this microprocessor present? This microprocessor is present inside the motherboard of a computer. Okay, it is present inside the motherboard of a computer. Okay, this is a microprocessor. So CPU is called as the heart of a computer system. Okay, so microprocessor is performing all the functions of a CPU. Hence, microprocessor is also called as the heart of a computer system. Okay, microprocessor or otherwise known as a CPU. Okay, see, this is a diagram of a basic MPU unit, that is microprocessor unit. While seeing this, you may remember that this is a block diagram of a CPU. Yeah, this is a block diagram of a CPU because microprocessor is otherwise known as a central processing unit. Okay, see, this has ALU unit, control unit, registers or arrays. Okay, what is this ALU unit performs? It performs arithmetic and logical operations. Okay, we all know that basic arithmetic operations are addition, subtraction, multiplication, division. And we all know about what is the logical operations, that is logical or, logical not, logical and logical NAND, many logical operations we are performing. So what is a control unit? It controls the signals. Okay, it controls the signal between a processor to other peripherals. Next, what is the register array? Array is nothing but where there are set of registers, it is called as a array, or a group of registers are called as a array. In a microprocessor, we are having a B register, C register, D register, E register, H register, L register, and accumulator, which is also as a register. This we will use very often as a temporary storage. Next one is a memory unit. This whole CPU unit is called as a heart of a computer system, whereas this memory unit is called as the brain of the computer system. Okay, for human being, we are having a brain. What our brain is performing, it will insist us to do work and also to store the informations. Our brain is useful for us. As like that, in a computer system, this memory unit will store the informations. Okay, this main functions performed by this memory unit are encoding function. Okay, encoding, and it will store the data. It will retrieve the data when user needs. Okay. These are the main functions of a memory unit. There are two types of memory in a microprocessor, that is RAM. RAM is nothing but a random access memory, and ROM, that is a read-only memory. This random access memory is a volatile memory. Volatile means this is a temporary storage, whereas read-only memory is a non-volatile memory, which is a permanent storage. Okay, this is the memory unit. What is encoding we need to know. Okay, before that, let me discuss how this encoding will perform. Here we are having an input device. Input device is nothing but what the user is giving. Okay, for example, if I am giving an input, okay, I will give to the input device only, right? I will not give to memory. So to input device, I will be giving an input. This input device will give the input to the memory unit because the input will be in a form of a user language. Okay, if I am giving an input in English, this input device will give the English input to the memory unit. What this memory will do is, it will not directly send that English input to the processor because this processor is a one IC. This IC only knows digital values. So digital values means it will take only binary values as a input. So it don't know to compute the in other languages. Okay, so What this memory unit will do is, it will encode the given data. What is encoding then? Which it converts user language into a binary values to a computer understandable form is known as a encoding. Okay, once the data are converted to binary values, this memory unit will send to the microprocessor unit. What this microprocessor will do? It will perform the operations. Okay, before performing, once the encoding data are ready, this processor will fetch the instructions from the memory. Okay, what does mean by fetching is that it is just taking an instruction from a memory. Once the instructions are taken from a memory, this will start to perform. Before performing, what it will do is, if it performs in a binary value itself, it cannot give the output to a user-defined format. So what it will do is, before executing the operations, it will convert the zeros and ones to a user-defined value. Okay, so the zeros and ones are converted into a user-defined language. This is called as decoding. Okay, this is called as decoding. What is decoding then? Which it converts binary values to user-defined language is called as a decoding. Once it is decoded, then it will start to execute the operation. After execution, the data will be stored in a memory. Again, the processor will send to the memory unit. Here in a read-only memory, it will store the data. Okay, because it is the triggering unit. Okay, all the data are stored in a memory. Finally, it will be returning back to a output device, that is to a user device. Okay, this is the basic block diagram explanation of a microprocessor. Okay, this microprocessor can perform multiple tasks in a single IC. It has implemented a task of a central processing unit. Okay, this is the basic block diagram of a microprocessor unit. See, next is the functions of a microprocessor unit. See, it controls all the parts and send timing signals. Okay, it controls all the parts of a computer and sends a timing signals. Okay, here we are using this in only a computer system, so it controls all the parts of a signal. Okay, next it's a memory device. It acts as an interface between a memory and a I/O devices. So this input is for giving data to the memory. What this memory will do? It will encode the signals. Okay, what this memory will do? It will encode the data and send to the processor. Once the data are encoded, what this CPU will do? It will fetch the instructions from the memory. Okay, fetching is given to the CPU. The CPU will perform all the functions and again it will return back to the memory for storing. Okay, before executing, what it will do? It will decode the data. What is decoding? Which it converts from binary, that is 0 and 1, to a user-defined language is known as decoding. So after decoding it, it will perform the operations. Okay, what operation the user demanded, it will be performing. After that, it executes and finally it's sent to the output devices. This is the main functions of a microprocessor unit. See, this is the general block diagram of a microprocessor. In this, see, this is a separate IC. Okay, in what will be having in the CPU? What we had, that is ALU. Then what we had? Control unit. Then what else we had? Registers. Only this much will be in this IC. Okay, these all are in a one IC. Then this RAM is separated peripheral, ROM is a separated peripheral, IO port is a separated peripheral, timer is a separated peripheral, and serial communication is also separated peripherals. All are separated peripherals. Okay, so what this microprocessor will do is, it will have this alone in a single IC, and all the peripherals are connected together by means of this path. This path is connecting path is called as a bus. Okay, this RAM is nothing but it is a data memory. This ROM is a program memory. What is this IO port? It is an input and output pins. Okay, input and output pins. Next one is a timer port. What this timer will do is, it will produce the clock pulses. Okay, it will be having on a timer. Okay, what this will do is, here in a processor, internal clock will be present. Okay, internal clock will be present. So what this timer will do is, to between the processor and to the other controlling components, this timer will maintain a synchronization. Okay, this clock pulses and also this clock pulses will be same to maintain a stability. Okay, next one is serial port. Serial port is mainly for serial communications. Okay, and this all are connected together by a bus. There are three types of bus. One is a data bus, either is a address bus, another one is a control bus. Okay, if this is a data bus here given, this data bus will collect only data from computer to other peripherals. This address bus will collect only the set of addresses from processor to the other components. This control bus will only collect the control signals from the processor to the other components. Okay, this is the general block diagram of a microprocessor unit. See, there are some versions of microprocessor unit is given. In a first version, it is developed by Intel, and the microprocessor IC number is 4004. Okay, in a second version, they have given us 8085 microprocessor as a Intel companies. And now the latest version, we are using it as a Pentium Pro. What is the main differences between a Pentium Pro 8085 and 4004? This Pentium Pro is the latest versions. Now we are using it. This Pentium Pro can work in any platform. Okay, it can work on any platform, and any codings it can work. Any platform, any coding it can work. Okay, because this 4004 have separate coding, this 8085 have one set of separate coding, this Pentium Pro will have some set of codings, but this Pentium Pro can work on any platforms, whereas this 4004 cannot work on Pentium Pro platform, or 8085 cannot work on Pentium Pro platform. This 8085 can work alone only in a 8085 platform. This 4004 will work alone only in a 4004 platform. So the latest version is Pentium Pro, which it have this advantage, which works in any platform and any coding. See, there are some demerits and applications of a microprocessor. What is the main demerit is that the microprocessor do not have a built-in peripherals. What does the do not have built-in peripherals mean? That this microprocessor in IC it have only a CPU. Okay, that is only this alone in a one IC. All the peripherals like RAM, ROM, IO ports, all are connector by a means of a bus. So this will take separate space, this will take separate space, this will take separate space, this will take separate space. So all these will take a separate space. So its construction is bulky and its cost is high. It requires more power and space requirement is more. And in a microprocessor unit, as a secondary storage, we can use a hard disk drive. Okay, because this is the just like a computer system, we are using a microprocessor. Okay, next the main applications are surveying instruments, robotics. We can use an automobile as a microprocessor unit. Automobiles we can use mainly for fuel injections. Okay, in a fuel injection we can use this microprocessor unit. And also in various applications we can use this. In our daily life we are using this in a desktop computers. Okay, we all know that what is a desktop computer, and that we can use this. It can perform multiple tasks. Okay, but requires more space. Next, what is a microcontroller? Microprocessor and microcontroller. See, the microprocessor will be having in one IC, will be having this one CPU implementation alone. Okay, but in a microcontroller IC, you see, will have what are the things? See, will be having a CPU as a separate unit. Okay, this is a CPU unit, and we can have memory unit. Okay, that is, what are the memories we have? RAM and ROM. And what are the things we are having? Timers, timer, register, see, IO port, see, serial communications, SCON. See, this is a microprocessor IC. Okay, let's consider about 8085. That is a microprocessor IC. See, this is a microcontroller IC. Let's have a look about 8051. Now you know the difference. In a single IC, only the CPU operation alone can be performed in a microprocessor. Whereas in a microcontroller, in a single IC, we can perform all those things inside it. So it don't have any built-in peripherals. It have a built-in peripherals like RAM, ROM, timer, register, IO ports and SCON ports. Okay, this is the main difference between a microprocessor and microcontroller. This microprocessor don't have any built-in peripherals with it, whereas microcontroller have a built-in peripherals with it. Okay, these microcontrollers are otherwise known as embedded controllers. Okay, what these microcontrollers are known as? It is otherwise known as embedded controllers. Where we can use these embedded controllers? These embedded controllers are widely used in an embedded system. Okay, what is the embedded system? The embedded systems will have only a hardware and a software. It don't need any front-end operating system. Whereas this microprocessor is a computer system. It needs hardware, software and a OS. Without OS, this microprocessor cannot run. But this microcontroller don't need OS. Okay, operating system. It don't have any operating system. It have only hardware and software, so that this microcontroller can use in any of the devices. In any small micro devices, we can use this microcontrollers. Okay, this in a computer system, microprocessor is the heart of a computer system, whereas in embedded controllers, the heart, it is the heart, microcontrollers are the heart of the embedded system. Okay, it is an heart to an embedded system. What? Microcontrollers. Okay, this microcontroller can do only a specific function. Okay, if I'm using one microcontroller for temperature control, it will control only the temperature. If I'm using a microcontroller for pressure control, it will control only the pressure. If I'm using it for humidity, it will control only the humidity. But this microprocessor will perform multiple tasks, but it requires more space. Okay, in a small device, I can use number of microcontrollers to control various functions. In one device, I can control temperature, I can sense the gas control, pressure control, humidity, anything I can use. But for all the devices, all the controlling functions, I need a separate microcontroller. So in one device, I can use number of microcontrollers, but microprocessor cannot use like that. Only one microprocessor can be used in a system. But that one microprocessor itself will do many tasks. Here, the microcontroller will do only specific function, but we can use number of microcontrollers. Even though I'm using a number of microcontrollers, I don't require more space for this operation. But for the microprocessor to control multiple tasks, I need a more space. So to less expensive and to consume more power, I'm using a microcontrollers in various applications. These are some of the types of microcontrollers. Okay, this Atmel is a company developed area. Next, Atmega microcontrollers, PIC, programmable interface controller. Next, 8051. This we will use in many of the applications nowadays also, and we'll also going to learn about this 8051 in a brief. Okay. Next one is Arduino. Arduino is neither a microprocessor or a microcontroller, but it's just on development board. I can use it as either a processor board or as the controller board. I can use this. Next one is ARM. This ARM is an advanced RISC machine. See, basic block diagram of a microcontroller unit. See, this microcontroller unit is the single chip. This diagram only I have drawn in a previous slide. Okay, so this alone will be accommodated in a single IC. Okay, processor unit, ALU, register. This is the what unit? This is a CPU or a processor unit. See, this is a ROM unit, RAM, timers, serial communication and I/O ports. Okay, next, what is ROM? This ROM is nothing but it is a read-only memory. Okay, what is this ROM? This is a read-only memory. RAM is a random access memory. Timers, serial communication, I/O ports. Processor will process the operations. ALU is a arithmetic and logic unit. Registers. Okay, all these will be accommodated in a single chip. Okay, next is in this 8051 we are having many types of register. A register is a general purpose register and also a special function registers we are having. Okay, this ROM is a read-only memory, RAM is a random access memory, timer, serial communication, I/O ports. Okay, why to use this timers? It will produce as a clock pulses. Okay, it will produce a clock pulses. So this clock circuit will also produce a clock pulses. All the controllers or processor will have an internal clock. Okay, so this clock circuit also produce pulses. So to maintain synchronization in a controller, this is used. This timers is used to maintain synchronization. The serial communication is otherwise known as a RS-232. Okay, if I'm using number of microcontrollers in a device, so it will enable one microcontroller and serially it will enable the other microcontrollers also. This is the work of a serial communication, to give a communication serially. Next one is the I/O ports. What is I/O ports? These I/O ports have some ports, okay, and it will have IO input pins and output pins. Okay, IO pins, that is input and output pins. If I'm giving an input, just consider one small example as an iron box, okay, or a toaster, anything. See, have a look of an iron box. Okay, in our house we are using iron box. So I'm setting a temperature internally. Okay, internally as an input pin, I'm setting a temperature of 50 degrees Celsius. Okay, internally I'm setting a temperature to an input pin. Okay, so what an iron box will do, once if you plug in the iron box, an LED will glow, right? A lamp will glow. So once the iron box gets heated, this lamp will automatically off. Or human beings are switching off that? No. Internally it is doing the operation. How it is? This iron box works on the principle of thermostatic principle. So internally I have designed, if this controller attains 50 degrees Celsius, okay, if you attain 50 degrees Celsius, what you have to do is the lamp should off. Okay, once if it reduced from 50 degrees Celsius, okay, if the heat is reduced to 50 degrees Celsius, again what you have to do, you have to switch on the light. Okay, in this, whether human interaction is there? No, we are not doing any interactions onto that, but into that, that is internally we have coded it. Okay, that is the work of IO ports. Okay, for input pin, I am giving an input as 50 degree Celsius. Okay, and once the 50 degree Celsius is reached, to an output port I have given an instruction at off. Okay, output connection is the lamp. Okay, input is the temperature setting, output is the lamp. Okay, input is the temperature setting, this is the input. Okay, what is the output? It is the LED glow. Okay, it may on or off. This is the output. Okay, okay, here internally I have set in temperature as 50 degrees Celsius as a input. Okay, so at beginning it will take a temperature 50 degrees Celsius. So when it reaches 50 degrees Celsius, what it will do is it will off. Okay, when it decreased to 50 degrees Celsius, what it will do? It will again switch on the start and it will again heat the iron box. This is the IO port. Okay, next one is an interrupt circuit. What is an interrupt circuit is that in a register, we are having one register, it's a special function register. So if my controller is doing one task, okay, that is a work of an A register. Okay, if my controller is doing a work of a register, okay, now the work going by a register. Okay, it is in processing. Okay, to an interrupt, this SFR register is coming. Okay, it is giving a task to the controller. But microcontroller can do only one function at a time. So it can do only A register. So to stop that A register, this interrupt circuit is used. What this interrupt circuit will do is, it will just pass the A register task. Okay, because this is special function register, so it will allow the special function register to process. Okay, once the task of special function register ends, it will start the again A register work where it passed and allow it to work. That is the work of an interrupt circuit. Okay, so as like if a VIP person is coming in a queue, okay, what the in a bank or in any area, what they will do, if a normal person is given a task to the worker, what he will do? He will do until the VIP person has come. If a VIP person has come, he will just tell to that customer, you just please wait, sir, we will finish this task and we'll call back you after 5 minutes. So within a 5 minutes, that VIP work will be completed. After that, they will call the customer and they will finish that work. That is the work of a interrupt circuit. Next one is a digital to analog converter. Digital to analog converter is that it will be producing a clock pulses. Okay, that is zeros and ones to a continuous value. Analog signal is that this analog circuit, there is a sine wave into a zeros and ones. Okay, this is the simple block diagram of a microcontroller unit. See, elements of a microcontroller unit. There are some main elements and supporting elements. So main elements are that processor. In a processor, what will be having? Will be having an ALU, and what else we have? We have a register unit. We have a control unit. Okay, these are all inside a processor. In a memory unit, we'll be having a program and data memory. Data memory is a random access memory and it is a volatile memory. Volatile means it's a temporary storage memory, whereas program memory is a read-only memory. It is a non-volatile memory. It is a permanent storage memory. Okay, so in permanent storage is that once the power have off or on, I can take in the data, whereas in random access memory, if the power goes off, all the data will be erased. That is a data memory. I/O peripherals we have learned. Next one is supporting elements. What are the supporting elements of a microcontroller? It's analog to digital converters, digital to analog converters, the system bus. So all the peripherals are connected by a pathway that is called as a bus. The system bus are of three types, that is a data bus, address bus, and control bus. Okay, what is a data bus is that it will only communicate between a controller to other components, other peripherals or other components. Okay, it will carry only data. What is the address bus? It will carry the only addresses from microcontrollers to other peripherals. What is the control bus? It is just transferring the control signals or communicating the controlling signals from controllers to other peripherals. This is the work of a buses. Next one is serial port. Serial port is that it will be sending a serial communication to a microcontroller. Because in my device I am using one microcontroller, is no problem. If I am using a number of microcontroller devices, its work is to enable all the microcontroller devices in a serial communication way. For this purpose, we are using a serial port. To transmit or to receive a data, we will use this serial communication. Okay, these are the main elements of a microcontroller unit. Next one is the internal architecture of a microcontroller unit. Okay, in a microcontroller, these all are connected in a single IC. Okay, these are the main elements. These are all the supporting elements. So central processing unit will be having a ALU. Next, what else we have? Registers, processors. We will have a control unit. We will have. Okay, these all are connected by means of a bus. Okay. Next one is a program memory. Program memory, it have a space of 4 KBs. It is otherwise known as a read-only memory. Okay. What is a random access memory? It is otherwise known as a data memory. This data memory is mainly used for temporary storage. This read-only memory is used for permanent storage. This data memory is a volatile memory. This read-only memory is a non-volatile memory. And this timer 0 and timer 1, it's a timer circuit. It is of low state and high state. Okay. Next, serial port. It is to enable the microcontrollers. We are using this serial port, as I have said it earlier. Okay, it will transmit or receive the data. Next, it has an I/O ports. Okay, which is the input and output ports. It has 4 ports: port 0, port 1, port 2, and port 3. This interrupt controller, it will interrupt when any special function registers come in. Okay, and here we are using an oscillator circuit. Oscillator circuit is mainly used for stability purpose. To stably maintain a circuit, this oscillator is used. Stability and for durability, we are using this oscillators. What type of oscillator we are using in the microcontroller is maximum will be using only a crystal oscillators, because crystal oscillators will produce a stable output. Okay. And bus control, the bus controls are of three types. What are they? Address bus, data bus, and control bus. Okay. It is acts as a pathway between a controllers to other devices. This is the basic internal architecture of a microcontroller unit. See, there are some types, merits, and applications of a microcontroller unit. This MCS51 is one of the type. This is a 8051. This 8051 only we are going to study in a brief. Okay. Next one is AVR by Atmel. Microchip technology have announced a PIC, that is programmable interface controller ARM. Merits are it have built-in peripherals, it's less expensive, power consumption is low, and applications, robotics and smart industrial applications we are using. Specifically we are using this in a digital signal processor, because here we are using what IC? Digital IC. Next, in microwaves we can use this refrigerators. Sophisticated microcontroller applications are in artificial heart operations or other organs. In medical department we are using a microcontrollers. In ocean going vehicles, spacecraft and aircrafts we are using this microcontroller units. See some comparison between a microprocessor and a microcontroller. See, this microprocessor will not have any internal bus connections, so it will be all separately connected. See, so this is a microprocessor IC which will have only a what? CPU. So in a microcontroller what will be having? We are having many of the peripherals. Okay, what are the peripherals we are having? Here we have CPU, here we have memory, here we have timers, next IO ports, serial communication registers will have. Here we have all those things also, but all are connected separately. Memory unit, okay, and IO ports, everything will be connected separately. Here all are connected in a one IC. So this here all it don't have any built-in RAM ROM. It have built-in RAM ROM. It's compute power on the chip with internal bus connections. Okay, directly it will not support. It will be connected through a bus connections. Here it is an integrated general computer. Next, it is the heart of a computer system. It is used only in a computer system. It is the heart of an embedded system. Microcontrollers are used in embedded controllers. Its expensive is more, it's less expensive, its power consumption is more due to this space requirement. Okay, its power consumption is less. Here are some examples of a microprocessor and a microcontrollers. The applications we are used is in desktop computers we can use microprocessor, and applications like in coffee makers, in bread toasters we can use this microcontrollers. That is in a small electronic devices we can use a microcontrollers, but microprocessors are used only in a bulky applications. These are some comparison differences between a microprocessor and a microcontroller. So how to choose the right microcontroller for project is, while selecting your microcontroller project, you need to consider about what type of microcontroller you need to use, and how about the speed of a microcontroller, what about the space of a RAM and ROM of microcontroller have, and number of IO pins, and its power consumption, and what are the softwares it will develop and it will support. All these things you have to know while designing a microcontroller project. Okay, this video we have discussed about what is a microprocessor and what is a microcontroller, what is the difference between a microprocessor and microcontroller. So in your forthcoming videos we will detailedly discuss about what is a microcontroller, and especially about 8051 microcontroller we are going to learn in a brief way. Okay, thank you.